Hello students, in the last video we have talked about the differentiability of a function, of a real valued function at a point. Now in this video we are going to discuss the differentiability of a function in its domain and the properties of differentiation based on the types of function. Okay, so let us assume that y equals to fx be a real valued function, and if it is differentiable then this limit should hold. Okay, and the derivative of y with respect to x is dy by dx, and same is equals to derivative of fx with respect to x, and the value of the derivative of y with respect to x by the use of limit is this, and the same is also called as the method for evaluation of a method for evaluating differentiation by using first principle method. Okay, and this limit is also equals to this, or we can say that if a function is differentiable at a point, then this limit should hold. Okay, and if we want to discuss the differentiability of a function in its domain, then the function should be a continuous function, and it should not have no corner in its domain. In its domain, then this limits hold for every point in its domain. Like in the previous video we have calculated the differentiability of this fx versus x at a point say P. Now the same differentiability can be checked out at any point in its domain, or if a function is continuous and have no corners in its domain, then the function is differentiable in its domain. Okay, now we are going to discuss the property of differentiation based on the type of the function. Okay, so I am drawing this. Now first we are going to find out what was the differentiation of a constant function. Okay, if we draw the graph of a constant function, this is y and this is x, so the graph of a constant function should be like this, y equals to c. And if we take 2 points x1 and x2, and if you assume that the corresponding value of this function at x1 would be fx1 and at x2 would be fx2, now we can see that the value is not changing with x. Okay, so this value should also be equals to c, and this value should also be equals to c. Now we find the derivative of this function by first principle. You will get here limit h tending to 0 f of x plus h minus f of x by h. Now in place of f of x plus h you are writing c, and in place of fx you are also writing c. The c minus c is equals to 0, which will give you the derivative of a constant function is equals to 0. What was the result of this? That is d by dx of a constant is equals to 0, or d by dx of c is equals to 0. Now in the second type of function, if a constant value is multiplied with that function, like we have a function like this, y equals to k times fx, and this k is some constant. So what was the property for differentiating this function? If we differentiate this, we will get here dy by dx equals to limit h tending to 0 k into f of x plus h minus k f x upon h. Now we can take the k common from both the terms in the numerator, and we will get here k into limit x tending h tending to 0 f of x plus h minus f of x upon h, and this will be equals to dy by dx of fx. This will be equals to dy by dx of fx. Okay, so first property would be dy by dx of constant is equals to 0. Second is dy by dx of k into fx is equals to k times dy by dx of fx. Okay, now I'm taking the third type of function, that is if we have a function like this, y equals to f of x plus g of x, and we are going to find the derivative of this function, then the derivative y with respect to x would be equals to, by the use of first principle method, f of x plus h minus plus g of x plus h minus f of x minus g of x upon h. Okay, now if we take this two term together and this two term together, we will get here limit h tending to 0 f of x plus h minus f of x upon h plus g of x plus h minus g of x. Now we can distribute this h to both term, and we can also distribute this limit, so we will get here limit h tending to 0 g of x plus h minus g of x upon h. So this will be equals to derivative of fx, and this will be equals to the derivative of gx. So this was the third property, that is if we are going to find the differentiation of two functions like f of x plus g of x, it will be equals to dy by dx of fx plus dy by dx of g of x. Or same, if there is a negative sign here, then here is also a negative sign, then this will become positive, and if we take a negative sign common, then this will change like this, and here we get a negative sign. So this will be the final if we both include this positive and negative sign. Okay, so if there is a plus sign, then this will hold. If there is a negative sign, then this will hold. Now the fourth property, if you have a function like y equals to is in the form of the product of two functions. Okay, so the formula that we get from this is product rule. Okay, and if you want to discuss the derivation of this product rule, you can check my next video after this in the playlist. This will give you the derivation of that product rule. So if you're going to find the differentiation of such function which are in the product form, it will be equals to d by dx of fx into g of x as it is, so I'm writing in left hand side of this, and plus f of x into d by dx of g of x. You have to find first the derivative of fx, and multiplying the derivative of fx into g of x, plus you are finding now derivative of gx, and making this derivative product with the fx and add both the terms. Okay, so that will be equals to the derivation derivative of fx into g of x. Okay, if you want to discuss the derivation of this product rule, you can check the next video of the playlist. And if the function is like that, f of x by g of x, then the derivative of that function would be equals to g of x into d by dx of f of x minus f of x into d by dx of g of x upon g of x whole square. Okay, and you can also check the derivation of this relation also in the video that is after the product rule. Okay, and this rule is known as quotient rule. Quotient rule. Okay, so these were the properties of differentiation based on the type of functions. Okay, so these are the 5 important points that one should remember for finding the differentiation of a function. Okay, and we have also made a separate playlist for finding the differentiation of simple functions by the use of first principle method. Okay, you can also check those on also my channel. Thank you so much. I hope that this video will be helpful for you. Thank you so much.